Welcome back, everyone. We'll start our class now immediately. So, with a quick recap of what we have learned previously, let us quickly have a preview of it. We were talking about what are the various importances of C language, why we are learning it. So one of the most important thing in C language was that it is simple in writing. So when we talk about simple, we know that C language is going to contain English-like type of terminologies since it is a high-level language. And C language is a structured approach to solve any problem. So when we are trying to use C language has been written in such a way that most of the tasks which are expected to be done have already been written in by certain developers. So those developers have already written major tasks which are to be done, commonly tasks which are to be done, and they have defined them as separate functions. Those functions they have kept in libraries. So C language is going to contain a lot of such functions already defined in libraries. Okay, so these libraries are going to contain a very rich set of already predefined functions which we can directly use. Fine. So apart from the functions, they also give a flexibility to define our own logic. So when we are trying to compute something, for example, addition of A and B. Now, when I say addition of A and B, A should contain some value. Let us say A is equal to 3. And B should also contain some value. B is equal to, let us say, 5. So A, B should be added up and their summation should be kept in another place, let us say C. And that C should will contain the value of that addition 3 plus 5, which is 8. But to a computer, what is A, B, and C? Is it just a character or is it a name of a place where we are going to store the value? The name of the place where we are going to store the value is called as variable. So when we are trying to use A, B, C as variables, we need to tell to the computer what type of values they are going to store, how long those values are going to be valid, and so forth, certain detailed information. That detailed information is called as data types. So C program is a structured approach to solve a problem. It contains a lot of rich set of predefined functions to solve our problem. But suppose if already existing predefined functions are not sufficient enough to solve our problem, then we can define our own logic. And while defining our logic, if we have to define certain variables, then we can use the data types to define them and work with our logic. C language is a machine independent language. It is written in high level language. It is not written directly in ones and zeros or system dependent code. It is written in machine independent language, in high level language. Since it can be executed onto multiple systems, it is portable. Remember Portable. Portable. Portable means the program which can be executed on different machines. Okay, if the program is not portable, then onto different systems, onto all different systems, we have to define the program once again pertaining to that system's requirement. Suppose you are working in a company now and you have written a program for, let us say, Windows operating system. Tomorrow your company shifts from Windows to Linux. Whatever programs you have written, whatever software you have developed till now will all get invalidated. You have to again write for Linux operating system. Will it be possible for you? Will it not become a headache? It will become a headache. So C language is a portable language. You need not rewrite it. You just need to recompile it on that particular environment. Okay. That's why it is called as machine independent. C language is also capable to work with mnemonics. If you are able to understand the mnemonics language, assembly level language, you can write your code in that particular middle level language also. And C, since it is a programming language, a program is written to solve a problem, C language adopts a strategy of structurally following procedure to solve the problem. It adopts a specific structure. You need to follow that pattern only to solve the problem. We'll come to know what is that pattern. We'll discuss about that particular slides. But do remember, C is a structured programming language. It adopts a well-defined manner in which you have to resolve a problem. Standards have been laid down to solve your problem. If there are no standards, you cannot just randomly go and solve a problem. It's awkward to go and solve any problem with a randomness. Okay. As we have discussed that C language is going to contain a rich set of libraries, here is the same thing being mentioned again, which we call as inbuilt functions or predefined functions. Both are the same. And C language is going to contain a feature which allows us to directly interact with the RAM memory space. That feature is called as pointer. With the help of this pointer, we can allocate memory dynamically. Suppose at the time of execution, I have said that there was a question in the program where it is going to ask how many students data you want to maintain. I have written 10 students. So for storing the data of 10 students, a memory will be allocated. Now suppose tomorrow the requirement changed, and while executing the program, the question was asked again to me, how many students data you want to store? Instead of 10, I am telling now 60. So I need not rewrite the entire code. The code itself will make a allocation for 60 different students. Memory will get allocated. So dynamically, at the time of running of the program itself, memory will get allocated. That's called as dynamic memory allocation. Now coming next, we have got C programming, which is very fast to get executed. With regard to all the high-level languages that exist in the market today, if you take the execution time which the program takes, compilation to execution, C language programs are the fastest to run on the system. Next, with the help of pointers, we will have the memory management to be done. We have already discussed about it. The second last one is recursion. Recursion means certain things you want to again and again execute by itself. You want to perform the task repeatedly. And the same task will need to call itself to perform. So when we have a function which calls itself from within the function, then that concept is called as recursion. We'll see why it is needed. Then the last thing, C programming, though it has a lot of features of inbuilt functions, it has got data types to be given, it has got memory management, everything. Apart from all that, if you are able to define your own logic, and you want to make that logic available for others to be used it, then you can define it and make the C extensible for your own logic. So those were the what we have learned yesterday. Now let us concentrate on the structure of C program. The structure of C program contains 7 parts. Documentation section, processor or link section, definition section, global declaration section, function declaration section, main function, and user-defined functions. These sections have to be written in that sequential order only. So first will come as what? Documentation section. The next thing that you have to write after documentation section is the processor links sections. Then the next thing that you have to write, third thing is definition section. Then you have to write global declaration section. Then you have to write function declarations. Then you have to write your main program. Then you have to write your user-defined functions. Without following this sequence, you cannot develop your C program. So you should keep these sequences in your mind. Which section should come in which level? So with that structure in our mind, with this sequence in our mind, let us try to see a brief introduction to each section, what that section is going to contain. Documentation section is going to contain the comments pertaining to what is the program, who developed that program, what is the purpose for that program, the name of the program, what is that program meant for, and who developed that program. You can keep your own sentences in that. Remember, comments will not be compiled or executed. Comments will be ignored. They will not be part of your logic. They are just meant for making your program to be more readable. So this part, documentation section, is optional. If you are willing to write the reasons for writing the program, then you can write. Otherwise, you can ignore. Clear? Second section is pertaining to preprocessor directives. We talked about the inbuilt functions library, reset of libraries, right? If we are using the predefined functions or inbuilt functions, we will not write the logic for it. We'll just use it. So when we are using it, we need to tell our compiler where exactly it is stored, where it is defined. For example, there is a function called as printf. Printf. This function is used for printing a message on the monitor. Now, as the printf function has already been defined by someone else, previously existing programmers, I will not write the logic for printing on the monitor. I'll just mention what is to be printed on the monitor. Now, when I'm using the printf function to print what I want to print on the monitor, I need to tell where is that printf function defined, in which library file it is defined. So those library files are called as preprocessor directives. So this preprocessor directive will contain a list of header files where inbuilt function logic is present. Next is a definition section. This definition section contains a list of variables which we are going to use in our program. Next is global declaration. Suppose a variable is such that we are going to use it in multiple functions, then we will define it globally so that it is available for all the program. Next is function prototype. Suppose when we are trying to solve a problem, the problem may be complicated. If you are solving a complex program, you will split that problem into multiple tasks. And you will solve first task, second task, and so on and so forth. Task 1, task 2, task 3 are considered as functions in C programming. So you are having a list of functions that you are trying to use to solve your problem. So you have to mention what is a list of functions that you are trying to use to solve your problem. That's called as function prototyping. You'll mention the name of the function that you are going to use to solve the problem, and you'll mention a list, how many you are going to use it. Apart from what is the function expecting the input to be and what type of value it is going to return back. So these things are called as function prototyping. You will not define that function completely. You will just mention what is the function name, how many such functions are being used, what are the expected inputs in that particular function, and what is that function going to return back. So next is main function. Main function is the function which is going to call all the functions which you have declared here. The main function acts like a controller. We'll call one by one all the functions to solve our problem. So this main function is considered to be the starting point of our program's execution. So execution of the program begins from the main function. Do remember this. In which order you are making a call to these functions is very important from the main function. Lastly, what functions you have mentioned here, listed here, you need to mention their logic. That's called as definition of your functions. So there are 7 sections that are there in the structure of your C programming. Those 7 sections are documentation section, preprocessors, link section, definition section, global declaration section, function declaration section, main function, and user defined functions. Now let us look how the programming looks like, a general view of the program. Keeping exact program, I'll give you the example program pertaining to it also. How it looks like. Comments will be written in this format. You will have a forward slash, then asterisk, then whatever you want to write, you will write as a comment. Then you will close that comment with a asterisk and then forward slash. Don't call it as a star. This is not a star. It is called as asterisk. ASTRIX asterisk. Okay, and this section itself is optional. Comment section is optional. Do remember this. Next is you need to mention a list of header files which you are going to use. These header files are going to contain the predefined functions which we are going to use in our program. Okay, those are called as preprocessor directives or preprocessing commands. You need to mention them. Then if you are going to use any variable in the main as well as other functions which you are going to define on, you need to mention those global declaration of variables also. Okay, then you have to mention your main logic. And in this logic, you can have local declaration of variables and some logical statements called as executable statements, all those stuff. And finally, you will define your functions, whatever functions you have listed here for writing your program. So this is a general overview about your program, structure of your C program. Let us try to see an example. This is exactly a code, how it looks like. So first we have the name of the program as a documentation section. I can write anything here. Do remember, here it is not a forward slash asterisk. If I have only one line of comment, then instead of writing forward slash asterisk, I will use two forward slashes. The comment ends when the line ends. That's it. So basically, there are two types of comments. One is multi-line comment. Second is single-line comment. We'll learn about it in detail in the coming units. Second section is about the preprocessor directive sections, which contains usually the header files. This stdio.h is standard input-output.header file. Conio.h common input-output.head header file. Okay, this files are going to contain the functions. For example, like printf is defined in stdio.h. These functions will be just used by us. Their logic will not be defined by us. Okay, so we need to include those preprocessor directives here. Next is a global declaration of a variable called as max, and I'm taking max value as 100. Maximum the value of the max variable can be 100. And I have one function to be defined. This is the prototype of the function. I am calling that function name as add. It is not going to take any value inside it, and it is not going to return anything. So whatever I have declared here, I have to define at the end of my program. User defined functions should be the last. Okay. So after declaring that function, prototype of the function, I am having one variable x whose value is x 100. So this x can be used in the main function as well as in the add function also. It becomes a global for main as well as add. Okay. Now within the main, I have got one variable a is equal to 100, which is my local for this main itself. This a cannot be used in add. It will be local only in the opening curly brace to the closing curly brace. Can you see it? So this a becomes the local variable for main function. And there is other logic that I'm writing here, some hello main or something like that has been written. And finally, the function has been defined. Add function, which we have declared here, has been defined. It's not doing much work. Just to give a glimpse of how the program looks like, I have kept this slide. Clear? So basically, in the structure of your C program, there are 7 parts. First one is documentation section. Second is preprocessor or link section. Third one is definition section. Okay. Fourth one is global declaration section. Fifth one is function declaration. Functions have been declared here. Sixth one is main function. It starts from the opening curly brace to the closing curly brace. Okay, then user-defined functions, which is this one, user-defined functions. Okay, I hope this particular slide is clear for everyone. Let us quickly revise back the overview of your compilation process. So whatever previous program we have seen, it will be passed as a whole, will be saved inside our name to that particular program. Let us say prg.c. And once this program is passed to our compiler, it will try to plug in all the preprocessor directives, include that code, and it will pass it on to assembler. Assembler will take whatever compiler has generated as assembly language code. It will pass it on to your linker. Linker what will take whatever has been generated from the assembler as object code. It will pass it along with the additional library files which are required for our program to be executed. Along with all those things, it will pass it on to loader. Loader will take whatever linker has generated, prg.exe, which is binary file, and it will try to allocate memory to it, and it will be passed on to processor for execution. Now, the same thing, let's explain different stages in converting the C program source code to execute. This question has been asked multiple times. So for simplicity, just to make you to know what you have to write your exam and examination, I have written few points here. So overview, our source program will be written in hello.c. Preprocessor directives will be substituted. So hello.c will get converted into hello.i. And after the hello.i has been compiled, errors has been removed from it, assembly level code will be generated and saved inside hello.s. This assembly level code will be assembled out by the assembler, and object code will be generated and saved inside hello.o. This hello.o is the object code. It is not ones and zeros. So whatever further inbuilt library files are required, those library files will all be included, and this linker will convert this object code into executable code, which is ones and zeros, which can be understood by the computer. Now this object code hello.o will become hello.exe. Now once it is hello.exe, it can be understood by the computer only when it is having sufficient memory. So to allocate the memory, loader will pick up that program, assign certain memory from the RAM, pass it on to some address space. That's all. Okay. The same steps have been written here. Please go through it. They are easy for you to understand. Same thing has been written. So what steps are required for your program to be executed practically? What do you have to do? The previous sequence which you have seen, you need not do anything in this case. All the work will be done by your C compiler. What you need to do exactly is written here. So what you need to do is first create your source code, write your program with the extension of .c. Once you have saved it with the extension of .c, now the question comes, where are you going to write the program? In the notepad or in the MS Word? No. You are going to write the program in a special software called as compiler. The compiler will give you an editor where you can write a program. Okay. So like one of these softwares which we will use for writing our programs is Turbo C. It has got inbuilt compiler inside it. So we will use the Turbo C's editor to write our program, save that program in our computer with the extension of .c. And once the program has been written, you will press Alt F9 to compile the program. The compilation will check for errors. If there are no errors, our program prg.c will get converted into prg.obj. Okay. Now, once it is converted into prg.obj, after pressing Alt F9, we will try to run that particular program or execute that program. So this prg.obj has to be converted into prg.exe. So in order to convert the prg.obj to prg.exe, we will press Ctrl plus F9 button. Okay, so you have to keep your control button pressed up, and then you have to press F9 both simultaneously Clear? Now, once you have done with the execution part, the program logic will get executed, and whatever result will become coming up, it will be written onto a output screen. To view the output screen, you have to press Alt plus F5. What you have to press? Alt plus F5. So basically, there are only 4 steps that you have to do. First thing, you have to open your Turbo C3, write your C program, and save it with the extension of .c. Once you have saved it, you have to press Alt F9 to compile it. In the third step, you have to press Ctrl F9 to execute it. In the fourth step, whatever result is going to come up, you have to see it by opening the user window by pressing Alt plus F5. Okay, these commands you have to remember. Alt plus F9 for compilation, Control plus F9 for execution, and Alt plus F5 for checking the result. Okay. The same thing has been written, since it can be asked in your examination also, the same thing has been written in the sentential formats also. So, though here a lot of steps have been mentioned, these steps, if you do it practically on the system, are very easy. You need not get into the complexity of the steps involved here. So compilation, what is it? One I have kept here. For executing your program, you have to press Ctrl F9, and in the execution, what it will do has been written in some more detailed format here, and checking the result, which is the last and final. The overall process, let us quickly revise back. What you have to do, you have to type the C program in the C editor. Let us say Turbo C3's editor. Save it with extension of .c extension, or press F2 to save. That's it. Okay. Then you have to press Alt F9 to compile the program. When you are compiling the program, the compiler will check for the errors in the program. If there are any errors, it will list out the errors to you. You need to resolve those errors. And once all the errors are gone, if there are no errors, then you need to press Ctrl F9. And once you press Ctrl F9, your program will get executed on your computer, and whatever output is generated, it will be put it onto user screen. And to check that user screen, you have to press Alt plus F5. So here is one quick overview about your entire process. You have written sample.c, you have pressed Alt plus F9, you passed on to compiler. This compiler is running from here to here. Okay, it will convert the .c program to .obj program. Linker will pick up all the header files, link it together, generate it as sample. Once sample.exe is present, you will press Ctrl plus F9. And this pressing Ctrl plus F9 will initiate the processor to execute your code, and it will generate an output. That output will be put it onto user screen. Okay, clear? So here is the one more assignment, the second assignment that is expected in this particular unit. You need to list and explain the steps involved in the execution. So these steps are nothing but starting from here onwards. From this line onwards, you need to mention what you are going to do in the first step. Then in the second step, what you are going to do. Then in the third step, what you are going to do. And in the fourth step, and the overall. So you have to write this assignment and submit it, and I will ask it. So a quick overview about have we completed all the topics that were required to be completed in the first unit or not. So state different steps involved in problem solving have completed in the first phase. Define algorithm and know its characteristics. Yes. State the steps involved in algorithm development. There were 4 steps involved in algorithm development. Develop an algorithm for simple problems. I have given you some slip tests also, apart from what I have presented. Then define flowchart and know the symbols in the drawing charts. This has already done. Draw flowchart for simple problems. Whatever problems I have mentioned here, the same problem has been taken as example for flowchart also, and I have given a slip test pertaining to that also. Then differentiate between algorithm and flowchart that has been listed out in sentential formats. You were expected to convert it into pointwise. Then define program and differentiate between program algorithm that has been done. High level language and low level language, these are the two categories which we have seen. Now, what is a compiler, what is a assembler, what is a linker and loader, we have seen in detail. What is source code, what is assembly code, what is object code, and what is machine code. We have defined them and we have seen in detail what they are going to contain. State the importance of C language. I have given you 10 different importance of C language. Then the structure of your C program, 7 points were there in the C structure. 7 components were there. We have seen in detail what each component is going to contain. List and explain different stages in converting C program source code to executable code. We have seen all the stages over there. And finally, explain steps involved in executing your program. 4 steps were involved. We have seen all those things. Thanks for learning the first unit. If there is any doubt for you, I'm available. Please put it up, either in the chat box or you can just unmute yourself and ask me. If you feel that we have not completed any of the topics here, we'll just quickly go through. I'm waiting for you. If there is any doubt, you can just. Is this unit clear for everyone? Do you want me to repeat any of the topics from here?
No, sir.
Okay, thank you. So, inshallah, tomorrow is Republic Day. It's a holiday, and day after tomorrow is 27th. We'll start with our second unit from 27th onwards.
Okay.
Fine.
Okay, sir.
Okay, thank you, Nandini. Thank you, Bhavana. So, is there any other person who is having any doubt in this unit?
No, sir.
Good. Thank you. So, let's finish off with our session, and on 27th, we'll again meet up. And lastly, I'm just expecting you people to submit your assignments. Honestly speaking, the purpose of generating all this classwork and all those things, PPTs and everything, it is appearing as if it is just meant for 10 to 12 members. I think there are more than 50 students in our class. If they are really interested to learn, I'll just extend the joining time in the class. Otherwise, I'll just ignore it. At present moment, I have got my first test responses from only 4 members. Only 4 members have handed over the work, and in case of second slip test, only 3 members have handed over, and for the assignment, only 3 have handed over. CRs, just keep a message in your own groups that if the same thing goes on, there are 6 units and each unit will contain 2 assignments. That means there are 12 assignments. Out of the 12, you need to write without fail 10 assignments within the due date time. And if you're not writing 10 assignments, you're going to lose 20 marks in the final. It all depends on your own skills and ability. If 10 assignments are not submitted, then they are not going to get marks in their finals. Do remember 20 marks are meant for assignments and slip tests, which I am going to keep a track of. And to keep a track of who has submitted and who has not submitted, I have kept this particular Google Classroom. No one can cheat anyone here. You have to submit it, and on what date and time you are going to submit it, who has submitted it and who has not submitted it, it will be all given automatically over here. And the marks will also be allocated over here automatically in the Google Classroom. So it's better if the class members are not interested to do the work to simply drop out from the entire subject itself. Okay.
Okay, sir.
Just let us quickly finish up our session. And on 27th, we are going to start with our second unit. And for the second assignment, I'll give a due date in the coming on days. Okay. Thank you, everyone.